Hi, in the last video we discussed about rift valleys. This time we will be talking about mid-ocean ridges or oceanic ridges. Okay, so if you noticed from the video last time, we showed you that when you have two plates or when a plate diverges, a crack develops at the center, it develops a boundary between uh, the two subplates that are formed. And then the ground at the center where the crack develops has nowhere to go but downwards, so you develop a rift valley. But as you may have noticed, that this rift valley again develops into lakes and then sea and then eventually into the ocean. So when the ocean, when it develops an ocean and the thing still is still rifting, technically speaking, you can still call it a rift valley, right? But um, for clarity, we often call it as an ocean ridge at this point. So um, it's still the same phenomena. If you think about it, it's just a continuation, right? So the continental uh, plate splits into two. There's a depression, develops a Great Lake, develops a sea, develops an ocean. And then when the rifting still continues, you will still have a structure of where there is a crack in the middle and there's a depression in the middle, but this time it will be under the ocean. And again, technically speaking, you can still call it a rift valley, but again, for clarity's sake, we at this point we now call it an oceanic ridge or a mid-ocean ridge. Okay, so if we go back to our definition of an, if we look at the definition of a mid-ocean ridge by Webster, it says here, an elevated region with central valley on an ocean floor at the boundary between two diverging tectonic plates where new crust forms from upwelling magma. So see, it's really just the same. It's a central valley, so it's like a rift valley, and the structure still is rifting, so it's a rift valley. But when it is under the ocean floor, right, it's often better to call it a mid-ocean ridge or an oceanic ridge, just to differentiate it from the structure that is formed in continental crust, which is a rift valley. Okay, but again, you wouldn't be wrong if you say rift valley, but again, for clarity, we call it a mid-ocean ridge or an oceanic ridge if it is now found underwater. But again, as you can see from here, it's just the same process. Two parts of the plate are rifting, a depression is formed. It's just that this time, that rifting is now under the ocean, right? But it's still the same. So why do we call it a mid-ocean ridge? Well, what is a ridge first? So in geology, a ridge is just simply an elevated uh, part or structure. Okay, so like mountains, right? So technically speaking, these are this can be called ridge. But again, let us take note of the difference. Okay, so first of all, when you have continental plate or when you have continental, well, part of the plate with continental land, again, continental crust contains two layers: the basaltic layer, right, of rock, and then the granitic layer of rock. So it's quite thick, right? And when there is divergence in these types of plate, again, just like everything, just like what we said before, a crack develops at the center, right? And again, because of that crack, this depresses. So therefore, at first, that depression is just like this, right? So it doesn't reach the basaltic layer, right? And so we call this a rift valley. And then again, uh, when that progresses, that depression all the way reaches to the basaltic layer. And again, at that point, because the basaltic layer, remember, ocean floor is made up of basaltic layer. So that's basically sea level, or not even sea level, but below sea level. In fact, that's the ocean floor already. So therefore, chances are when rains collect again, water would be collected here, and again, by that time you create Great Lakes, right? Uh, and if this rifting continues, right? So if this progresses even more, so now the continental land are far apart from each other. It's like this, right? And then you have the basaltic layer here, and then you have the collected rainwater, or this time it's now seawater because it's now become an inland sea. Again, the whole thing, the whole process still continues, meaning magma still upwells here. There's still a crack, but this time the crack is in the basaltic layer already, right? And again, by that time, we call this a mid-ocean ridge because now it's now under the sea, right? So it's really that's the only really that's the only difference between a rift valley and a mid-ocean ridge. And again, let me clarify. Technically speaking, you can still call it a mid-ocean ridge, but again, it would be more correct to refer to it as a mid-ocean ridge when it's already under the water, or where when it is already occurring in oceanic floor, right? But so, sir, if we have a test, can I answer Rift Valley and be correct? Of course not, because again, we have to be specific. And again, when you have a test, we choose the best answer. So while you can say that Valley is also the same as Ocean Ridge, the best answer would be Mid-Ocean Ridge because it's more specific to that case when it happens under water. Okay? So that's I want to illustrate a point here, and the point is, what was the definition of a mid-ocean ridge? Well, ridge is an elevated body part or structure, and again here you have here a central valley. So there's a depression in the middle. So again, you have to be careful about this stuff because uh, things change because of perspective, right? So if you have ground like that, and then that ground at the center collapses, right? Yes, if you are standing here in the valley, then you can say that this part is elevated part, and this part is also an elevated part, right? And this is a depression, right? But again, there are two perspectives. You can say, well, no, if I'm from here, this is not an elevated part. This is just the ground level, and that's a part where it's where there's a depression. But from his perspective, he would say, well, this is the that is the elevated part. The two sides are elevated, and this one is the. I mean, if I base it from here, these two sides are elevated. But again, for a person that is observing from the top here, he would say, no, this ground is not elevated. This is the ground level, and you are the one that is in the depression. So again, those two terms sometimes in books they are confusing because uh, people would say an elevated part or depressed part, but again, it's just perspective. So my point is, in some books, mid ocean ridges is sometimes called underwater mountains or underwater mountain ranges. So they are referring to it as a mountain range, which means a chain of mountains, right? But again, um, it depends on, I mean, you have to understand the process in order to kind of understand what they mean by that. So in the seafloor, in fact, I can show you that now. I have here Google Earth, right? And then if we look at the middle between the middle of Africa and South America, you have here the an oceanic ridge, right? And if we zoom in to this oceanic ridge, there are really cracks in the ocean floor, right? But if you were so from this perspective, it's crack. They are just cracks. So meaning they are depressed areas of the Earth's crust, right? But if you were at the center of this crack, obviously when you look at the sides, you see an elevated part, and you look at the side, that's an elevated part. So from your perspective, it's like underwater mountains, right? And we have to remember when the people discovered these structures, obviously they had nothing to compare their observations with because they are underwater. So if you see an elevated structure, your the first thing that comes into mind is it's a mountain. But it could have been just it's the ground level and there's just a depression, right? So so it's like that. So that's why I don't like the term underwater mountain range, just because it gives you uh it gives people some confusion because they would say, okay, mountains. I thought mountains were created by convergent boundaries. How come a mid-ocean ridge is created by plates that are diverging? Then how come it's called an underwater mountain range? Again, there are two explanations for this. Again, it could be that this is the ocean floor, and because this plate moves that way and that plate moves this way, again, it could be as simple as the crack occurs here. And obviously, from the perspective of that crack, if you're at the crack at the center, you would see this as an elevated part at the sides, at the two sides. So again, that's why you say it's a mountain range. That's the first part of the explanation. The second part of the explanation is, of course, it's a crack. And magma upwells in that area. So when it upwells in that area, meaning magma comes out here, and I could and you could imagine that if magma upwells here, the magma would come out and kind of be deposited at the sides, right? Be deposited at the sides, be deposited at the sides. Obviously, the center would still be a depression because even if, let's say, you deposit magma there, when they move, when these two plates move, obviously the magma at the center will eventually depress. So over time, what you can see are just the magma deposits at the sides and then the crack at the center. So again, when submarines discovered this, all they saw was this kind of elevated parts here because of the magma coming out, right? And therefore, they labeled it as underwater mountain range, right? But again, this is kind of misleading just because the way we understand mountains, it's created by two plates that are converging, right? Two plates that are converging, they crumple the material upwards, so they form mountains. So in this case, um, it's hard to reconcile that again these two plates are not converging, they are diverging, and yet how come they form mountain range? So again, I don't like the term underwater mountain range. I like the term. It's that it's a crack in the middle of the ocean floor. It's just that because of that crack, magma upwells. It gets deposited to the sides. So therefore, when you visit it, you would see kind of a depressed area at the center, and then kind of mounds of mounds of what used to be magma material that has solidified already at the sides, and these could be interpreted as underwater mountain range. But again, that is the idea why um, people call it an underwater mountain range. But again, the better term for me, I believe, would be it's really a giant crack on the crust of the Earth's surface underwater because the plates that are in there are moving apart. Okay, but be aware that there are certain books that call it an underwater mountain range, and again, I'm just explaining why that is to avoid misconceptions. Just because it's a mountain range, it's not created by convergent boundaries. Again, it's just a combination of perspective because again, when you're underwater, you see this, there's no structure, right? When you are in the ocean floor, there are no trees or other things that you can compare your perspective to. So obviously, when you see elevated areas, the thing that comes into your mind is this is like mountains but underwater. So thus the term is like that. But again, I kind of don't like this term. It's misleading. I'm not saying it's correct, it's wrong. I'm saying it's misleading in terms of how we organize our concepts of uh, how these geologic features are formed. So, in other words, this is nothing more than just a continuation of a rift valley. Two plates diverge, forming a crack at the center. When it was still in a continental plate, obviously, when it depresses, uh, it goes to the basaltic layer because the granitic layer depresses. At that point, we still call it the rift valley. But when it progresses and now water collects in it, and it's either it becomes a great lake. When it's a lake, you can still call it an oceanic ridge because it has not formed a sea. But when it progresses and it becomes an inland sea and eventually becomes an ocean, and the rifting still continues, it's technically more correct to refer to it as a mid-ocean ridge. So that is how mid-ocean ridges are created. So here, again, you have the mid-ocean ridge stretching, separating the continent of Africa and South America all the way up to here, even up to Iceland. Iceland is actually in the middle of this oceanic ridge. So this line here, this crack here, runs through Iceland like that. Okay, and just to connect your concepts with the previous discussion, again, I showed you Great Lakes in Africa. So right now, we see these Great Lakes from somewhere in Malawi, in Burundi, in Rwanda. These are cracks. And at this point, we still call it rift valleys because, this is still continental land and this is still continental land. It's just that there's a depression in the continental land. Technically speaking, this is rift valley, but what we're saying is that if this movement continues, this part of Africa will actually separate from the mainland Africa. So here we have this part. So these parts here, they will actually move away from mainland Africa. And when it does, that means there will be an ocean developed here. And when it does that, it's it's just the same as what happened to Africa and South America. We can surmise that this South American continent and this African continent were once joined together. They were one continent, and then they developed the Rift Valley, which eventually turned into Great Lakes, and then a small inland sea. Then that small inland sea separated and rifted and rifted and rifted, and then you form an ocean in between them. So, what happened to Africa and South America is actually what is happening right now in East Africa. So the East African Rift System is the early stage of formation of an ocean ridge. So again, um, the discussion on Rift Valley and mid-ocean ridges are ultimately connected because again, they are the same phenomena. It's just that when it starts in a continent, you call it a Rift Valley system, right? And then it develops into a sea, and then the process continues, and the structure that you find under the sea, under the ocean, is technically called a mid-ocean ridge.